In this video, we will be doing some examples of adding and subtracting fractions. So when adding or subtracting fractions, you must have a common denominator. So here is a little how-to to add or subtract fractions. So the first thing is, do they have a common denominator? If the answer is yes, then go to step 2. Go ahead and add or subtract, and then simplify. If they do not have a common denominator, then you need to find the LCD and rewrite each fraction with the LCD. So you're going to make equivalent fractions for each of the two fractions, or however many fractions you have, and then continue with step 2. So in order, again, to add or subtract fractions, you have to have a common denominator, which means the pieces mean the same thing. If you don't have a common denominator, then the pieces are different sizes. So you want to be talking about something that's the same when you're adding stuff together. So for number 1, we have 6 over 13 plus 5 over 13. The denominators are both 13, so we can simply add. When we add fractions, we add or subtract the numerators and leave the denominators the same. So this is going to be 6 plus 5 is 11 over, the denominator stays the same. 11/13 is in lowest terms, so that's it. Number 2, we can see that both of the denominators are 8, so they already have an LCD. So we're just going to subtract the numerators. 11 minus 7 is 4. So 4 over 8, and that can be reduced. Both 4 and 8 have a common factor of 4, so I could divide out a 4 from each one, and I will be left with 1/2. Number 3, the denominators are both 16. So since the denominators are the same, we can subtract. This one really, since they're both negative, we're really adding the numbers and keeping the sign. So we have a -3 and a -7. So that would be a -10 over 16. This can be reduced. It looks like 2 is the common factor. So we'll have a -5 over 8. Number 4, we have a common denominator already. It's 13. We have different signs. We have a -4 and a +9. So in this case, we'll take the difference of the two numbers, which is 5. 9 minus 4 is 5. 9 is a larger number than 4, so since it's positive, we'll keep the answer positive. And I said that and still wrote a negative. So it should be a +5/13. Number 5. You can see that here the denominators are not the same. We do not have a common denominator. So the first thing we need to do is figure out what the common denominator would be. If you're finding a least common denominator, you can use methods such as finding, you might could just do it in your head, or you might use the factor tree and find the least common multiple between the two numbers, and that would be your least common denominator. If both of the denominators are prime, then you just multiply them together and that will be your LCD. So 2 is prime and 7 is prime. So since they're prime, 2 times 7 is 14. That's going to be your common denominator. So our common denominator is 14. Our LCD is 14. So we want to be able to scale each of the fractions up to an equivalent fraction where the denominator is 14. So what you want to do is you take your denominator that you want it to be 14, and you divide it by the denominator that's actually there. So 14 divided by 2 is 7. So that's what you're going to multiply by to get 14. Whatever you get for the denominator, you're going to use that to multiply the top as well. That's what's going to keep it an equivalent fraction. So 1 times 7 is 7. So the first fraction would be 7 over 14. Now you're going to do the same thing with the second fraction. So you want the denominator to be 14, so you're going to divide that by 7, which is what's actually there. 14 divided by 7 is 2. So you're going to be multiplying the top and the bottom by 2. 2 times 1 is 2. So your second fraction would be 2 over 14. Now you have a common denominator, so we're just going to add the numerators. 7 plus 2 is 9. So 9/14 is your answer. 9 and 14 don't have any common factors, so that's in lowest terms. All right, number 6. So the first thing, even before I look at the denominators, I don't like to see two negatives back to back. So remember, the way we can handle that is we can make the two negatives, a negative times a negative is a positive. So those just kind of morph into a big plus. So I'm going to rewrite this as 1/4 plus 1/8. Now I can look at my denominators. I don't have a common denominator, so I have to do that first. If you don't see what the least common denominator is, again, you can make a factor tree to find your prime factorizations and get the least common denominator. If you don't care if it's the least common denominator, you just want a common denominator, you can always just multiply the two denominators together. So if you really don't know how to find the least common denominator, just do 4 times 8. I'm going to go ahead and go through the steps of finding the least common denominator. So 4 is 2 times 2, and that's done. I can't break 2's down any further except for 2 and 1. And then 8 is 2 times 4. 2 can't be broken down any further, but 4 can. 4 is 2 times 2. And so that's as far as I can take each part of that. So my lists here, I have 2 2's, so 4 is 2 times 2, and 8 is 2 times 2 times 2. Oops. So we use each different factor. Well, 2 is the only factor that we have, and so then we want to use the one that appears the most. So there's 3 2's in this list and only 2 2's in that list, so we use the longer list. So our LCD will be 2 times 2 times 2, which is 8. So we want our fractions to both have a denominator of 8. So for the first fraction, I want it to be an 8, but I currently have a 4. So I do 8 divided by 4, and I get 2. And then I multiply the top and the bottom by 2. So I will get 2/8 for the first fraction. For the second fraction, I have an 8 and I want an 8. 8 divided by 8 is 1, so I'm not having to change this one at all. So this is still going to be 1/8. Now I have a common denominator, so I add the numerators. I get 3/8, and that's in lowest terms. Okay, we've got, I think, 4 more examples. So number 7, we have 7/12 plus 5/8. Again, these are not common denominators, so we're going to have to find those first. So let's do 12. 3 times 4. 4 breaks down into 2 times 2. And then that's as far as I can take that one. They're now all prime. So 3 times 2 times 2 is my list for 12. So 2, 2, 3. Now I can do 8. We just did 8 in the previous example. 2 times 4, and then 4 breaks down into 2 times 2. So we have 3 2's in our list, or our prime factorization for 8. So to find the LCM, which in this case the LCD, because it's the LCM of the denominators, we have a factor of 2. The longer list is 3 2's, so the 2 2's are kind of seen as repeats. And then we have a 3, and that's everything. So 2 times 2 times 2 is 8, times 3 is 24. So our LCD is 24. So now we want our denominators to both be 24. So if we want the first one to be 24, but right now it's 12, we do 24 divided by 12, and we get 2. So we're multiplying the top and the bottom by 2. 2 times 7 is 14. So our first fraction of 7/12, an equivalent fraction, is 14 over 24. We're going to do the same thing for the second. So we have 24. That's what, oh no, I'm sorry. We want it to be 24. We have 8. 24 divided by 8 is 3. So we're going to scale up the second fraction by 3 over 3. 5 times 3 is 15. So our equivalent fraction for the second fraction is 15 over 24. We have a common denominator, so we can now add. So 29 over 24. And those don't have any common factors, so that would be it. Notice that I left my fraction as an improper fraction, meaning the numerator is bigger than the denominator, and I am not changing it to a mixed number. So this is kind of a teacher preference. I think most of the time in higher education we like to use improper fractions and we don't change them to mixed numbers. Sometimes in K through 12, your teacher might like mixed numbers better. So you'll have to just kind of talk to your instructor or teacher about their preferences. But for my class, we use improper fractions. So we would leave it right there. Number 8, 16 and 12. So those are not, those two fractions do not have a common denominator. So we'll start by finding that first. So let's make a factor tree for 16. That could be 4 and 4. And then 4 is 2 times 2. And that would be prime on all the ends. So we have 4 2's. So 16 is 2, 2, 2, 2. All right, next we want to do 12. So 12 is 3 times 4. 4 is 2 times 2. Those are all prime. So our list would include 2 2's and a 3. All right, so our LCM, which in this case is our LCD. Each different number, so we're definitely going to include a 2 and a 3, but then we have to decide how many. So the 16 has a list of 4 2's. 12 only has 2. So we're going to use the longer list. So that's 4 2's. And then we also have to include a 3. So that's going to be 2 times 2 times 2 times 2 times 3. And I believe that's 48. So we want our denominators to both be 48. So to find out what we should multiply by, we're going to divide. Our desired LCD, 48 divided by what's actually there. So 48 divided by 16 is 3. So we're going to multiply the top and the bottom by 3. 7 times 3 is 21. So our first fraction is 21 over 48. The second fraction, we have a 12. We want it to be 48. So 48 divided by 12, we'll get 4. So we're going to multiply the top and the bottom by 4. Now we multiply, so 5 times 4 is 20 over 48. We have common denominator now. So 21 minus 20 is 1. So 1 over 48 would be our difference. Okay, 2 more. So if you're feeling pretty confident, you can go ahead and pause the video, try these 2 on your own, and then you can watch and check to make sure you're getting it right. So for this first one, number 9, we have a whole number. Remember that any whole number can be written as a fraction if you put it over a 1. So we have 3 over 1 minus 3 over 5. 1 is prime, and so is 5. So in this event, we just multiply them together, and that would be our LCD. So our LCD is going to be 5. So we want both of our denominators to be over a 5. The first fraction, we have a 1. 5 divided by 1 is 5, so we need to multiply the top and the bottom of that fraction by 5. So we have 15 over 5. The second fraction, we want it to be a 5. We already have a 5, so we don't have to change anything with that fraction, so it stays the same. Now that we have a common denominator, we can subtract. So 15 minus 3 is 12, and that's it, 12 fifths. Our final example, number 10, we have 1/2 minus 7/6. So if I want to find the least common denominator, 2 is prime, so I don't even have to make a factor tree for that one. It's just 2. 6 is 2 times 3. So short list here. We have a 2 and a 3. So our LCD is going to include each different number. So both lists include only 1, 2. So we're going to use 1, 2. The other one is a repeat. Remember, we only use the list from one of the two factors. We don't, or one of the two numbers. We don't use both of them. And then we'll have a 3. So our LCD will be 6. So we want the denominator to be 6. The first fraction, we have a 2. We want it to be 6. 6 divided by 2 is 3. So we're going to scale up or multiply the top and the bottom by 3 to get 3/6. The second fraction, we already have our desired denominator, so we don't change that one at all. It will be 7/6. So we can subtract now that we have a common denominator. So 3 minus 7 is a -4/6. These do have a common factor of 2, so I'm going to divide out the 2 from both the numerator and denominator and get -2/3.